Are you the student who are going to appear for JEE Mains 2026 January shift? Then definitely this video will be very helpful for you, because whatever the very important topics or the points are there for chemistry in respect of the JEE Mains in the form of grand test papers we are going to discuss. This is the grand test paper 1. Definitely helpful for you. Please like, share and comment below if you really like the video. Without any delay, let's get into the first question now. Read the following statements, and they have given 4 statements and asking us to select the correct option. So let's check one by one. If we consider the first IP of magnesium is less than that of aluminum. Magnesium configuration, we know it is a 3H2 configuration, so which is stable configuration and hence require more ionization potential in order to remove the electron, but they have given it is less. So the correct, it's not correct. The first one is wrong. Second one, O plus has lower electronegativity than that of O minus. If among O plus and O minus, if we consider the O minus, we need to give some energy to convert into O minus 2 because of the interelectronic repulsions. So definitely it will have lower electronegativity when compared with the unipositive oxygen, but they have given in a wrong way. So the second statement also wrong. What about the third one? Electron affinity of chlorine is less than that of fluorine. No. Among the whole periodic table, the highest electron affinity element is chlorine, but they have given it is less, so it is also wrong. What is the next one? Second IP of oxygen is greater than that of nitrogen. Second IP of oxygen in the sense, after losing one electron it converts into O plus, and if we consider the nitrogen, among these two there are 8 protons in O plus and 7 protons in nitrogen, and of course both are having the half filled configurations. So 8 protons O positive ion holds or helps the half filled electrons more tightly than the nitrogen, and hence it is greater, the second IP is greater than that of nitrogen. So the fourth one is correct. So the only 4 is correct, right? So this is how to analyze the statements. Okay, now let's move to the second question now. The correct statement regarding ClON minus molecular ion is. This question is based on the oxy acids of chlorine. We have a total of 4 oxy acids, that is hypochlorous acid, chlorous acid, HClO2, chloric acid, HClO3, and perchloric acid, HClO4. And based on the number of oxygen atoms, definitely the Cl double bond O groups increases, but it is no way connected to that bond order or bond length. Then what about the third statement on the increasing value of N, oxidation state or the number of central atom increases. See, with increase in the number of oxygens, here N means number of oxygens, no doubt the oxidation state increases, because if we consider the chlorine oxidation in the HClO hypochlorous acid, the oxidation state is +1. Here in the case of hypochlorous acid, the oxidation state of HClO is +1, +3 is in the case of HClO2, +5 in the case of chloric acid, and +7 in the case of perchloric acid. So with the increase in the number of oxygen atoms one by one, even the oxidation state also increases, and hence option C is the correct one. Now, third one. Which of one of the following is correct statement? Again, they are asking for the correct statement. Let's discuss in detail the each option. Option A. Cr plus 2 is an oxidizing agent and Mn plus 3 is reducing agent, though they are having both the D4 configuration. Listen carefully. Cr plus 3 converts in Cr plus 2 tries to convert into Cr plus 3 in order to get the stable T2G configuration, half-filled configuration. So it readily wants to undergo oxidation, means it is a strong reducing agent, but they have given oxidizing. So it's definitely wrong. And check Mn plus 2 also. Mn plus 2 wants to, not plus 2, plus 3, wants to be in the plus 2 state because to get a half filled D5 configuration. So though both are having the same D4 configuration, Cr plus 2 wants to attain half filled T2G, Mn plus 3 tries to attain half filled D5 configuration, and hence Mn plus 3 is a strong oxidizing agent. They have given in a reverse way, so option A is wrong. Now let's check the option B. Many copper compounds are stable or no, unstable in aqueous solution and undergo disproportionation reaction. Yes, especially in the aqueous solutions, Cu plus 2 ion is more stable when compared with the Cu plus 1. It is because of high hydration energy. High hydration energy, more amount of energy will be liberated when the Cu plus 2 ions, which is having the less size when compared with the Cu plus 2 plus 1. So more amount of energy will be liberated when Cu plus 2 gets hydrated, and hence tries to undergo disproportionation in the aqueous solution, that Cu plus 1, it converts into more stable Cu plus 2 or either to Cu, where the Cu plus is undergoing both oxidation and reduction, hence called disproportionation, right? So definitely option B is correct one. And let's check the remaining things also. Here if we consider the C statement, oxidation state of iron in Fe3O4 is fractional. Suppose if we consider Fe3O4, Fe3O4 is the mixed oxide, it is a mixture of both FeO and Fe2O3, in which the iron oxidation state is plus 2 and in Fe2O3 the iron oxidation state is plus 3. So the oxidation states are not fractional plus 2 and plus 3. In fact, the average oxidation state is fractional, but they did not mention average oxidation state. So this statement C also wrong. And what about the actinide contraction point here? Let's check the D option. Actinoid contraction is lesser from element to element than lanthanide contraction. Though we are very much familiar with lanthanide contraction, in fact the effect of actinoid contraction is more, and its contraction is much more from one element to the another element than that of lanthanide contraction, but they have given it is lesser, which is a wrong statement again. So option B is the correct one. Okay, now let's move to the fourth question. Increasing values of magnetic moment of the following species. Here they have given different coordination spheres. In order to check the magnetic moment, we need to look for the unpaired electrons that are present in the metal ions of these coordination spheres. The first one contains Fe plus 2 configuration, and second ion is Fe plus 3, third one is Cr plus 3, and fourth one is Ni plus 2. And here if we consider the configuration, this D6 configuration, 4s2 3d8 of losing out 3d6, after losing 2 electrons, it converts into D6 configuration with a strong ligand like Cn minus, the electrons will be paired up, so number of unpaired electrons are 0, and number of unpaired electrons for Fe plus 3 is definitely even after the strong ligand influence, one electron remains, so unpaired electron 1. In case of Cr plus E, the configuration is D3, and 4s0, those 3 electrons remains as these because the remaining ammonia ligands approaches through the remaining 2d orbitals direction. So it contains 3 unpaired electrons, and if we consider the last one, Na plus 2, 4 is 2 3d8 of losing 2 electrons, 4 is 0 3d8. That 8 electrons are not paired up because the H2O is a weak ligand, and hence you can say that there are 2 unpaired electrons with the Ni plus 2. So 3 unpaired electrons for Cr plus 3. So in the increasing order of this particular unpaired electrons, even the magnetic moment exists. So 1 less than 2, less than 4, and then 3. So you can see 1, 2, 3, 1, 2, 4, and then 3. So correct option is D. Now, the longest CO bond length will be with which metal ion? See, suppose if we consider this one, it's very important topic. We know already between the metal and the CO, there exists a synergic bond where the metal ions start donating its electrons to the antibonding molecular orbital of the carbon. And if that metal ion is having the high charge, especially the negative charge, then definitely after the donation of the pair of electrons, the bond between C triple bond O weakens, and if the bond between C triple bond O weakens, we can say that the bond length increases. So here if we consider the metal ions oxidation states plus 1, minus 1, 0, and minus 2, the titanium with the 2 units negative charge, after donating the pair of electrons to the antibonding molecular orbital of the carbon monoxide, weakens this triple bond O due to the repulsion, and hence the bond length increases, or and you can say that it has the longest C triple bond O bond length among all these coordination ions. Okay, so answer is D. Synergic effect or synergic bond is one of the important topic regarding the JEE mains. In any one of the shift, definitely you come across the metal carbonyls. So very important topic from coordination compounds. Now, assertion reason type questions. Boron always forms covalent bond. The small size of B plus 3 favors the formation of a covalent bond. Yes, definitely. Due to the small size and high ionization enthalpy, not only high IP, if we consider the polarizing power is very much high for boron, and hence tries to form covalent bond rather than the ionic bond. Not only the boron, if we consider lithium, beryllium, also tries to form the covalent bonds, or their compounds are covalent in nature due to small size and high polarizing power. That means almost all the first element of the second period elements forms covalent compounds. And hence both assertion reason are true and R is the correct explanation of A. Now let's move to the next question. Match the following column 1 and column 2. NH4Cl they have given. They're asking for the different chemical bonds here. And if we consider NH4Cl, it contains ionic bond, no doubt NH4 plus and Cl minus. And there exists a day2 bond between NH3 and H plus also, day2 bond. And in NH3 we have covalent bonds, but it does not contain any hydrogen bond. So regarding NH4Cl, PQS is the correct matching, right? Now let's go with the HNC. HNC contains only covalent and coordinate covalent, and there is a coordinate covalent from nitrogen to C, the lone pair donation here. So if we consider the HNC contains both covalent and coordinate covalent bond. And what about H2O2? H2O2, as it contains both oxygen and hydrogen, definitely it has that hydrogen bond, and we know H2O2 has a non-polar covalent bond also. Next one, regarding equivalent weights, list 1 and list 2 we need to match. In the list 2 they have given CrI3, which is oxidized into the Cr2O7 minus 2 and IO4 minus, right? So, and whatever the equivalence weights that are given in the list 1 based on the number of electrons that are involved in the reaction. So, total number of electrons. What does it mean? For example, if we consider CrI3, the oxidation state of Cr is +3 and I oxidation state is -1. It is changed to +6, that means 3 to 6 is nothing but 3 is the change. And in the case of iodine, plus A, here if we consider IO4 minus +7 is the oxidation state, -1 to 7 means total change is 8. And as there are 3 iodines, you can multiply with 3 so that you will get 24. 24 plus 3, 27. So, you can say that the equivalent weight of CrI3 in this conversion is nothing but molecular weight by 27. In the case of thiocyanates, iron thiocyanate for example, the oxidation state of iron is nothing but +2 and sulfur is carrying -2 oxidation state here, carbon is +4 oxidation state and nitrogen is -3 oxidation state. So, if we consider the iron, it is changing from +2 to +3, 1 is the change, and if we consider the sulfur, it is from -2 to, in the case of SO4 -2 it is +6, so -2 to +6, so change is 8. There are 2 sulfur atoms, so 2 into 8, 16. And if we consider the carbon, there is no change in the oxidation state of carbon, +4 as it is remains, right? And if we consider the nitrogen oxidation state changes from -3, here the oxidation state of nitrogen is -3, -3 to +5 change, so 8 is the change. As there are 2 nitrogen atoms, you can multiply with 2, so 2 into 8 again 16, so 16 plus 16 plus 1, that means 33 you will get. So 2 is matching with the P. And similarly, if we consider NH4SCN, the change is nitrogen. If we consider in the case of NH4 plus, or is there in the case of N, the oxidation state is -3, it is changing to NO3 minus, that means +5 oxidation state, 8 is the change, and there are 2 nitrogen atoms. And if we consider the sulfur, sulfur oxidation state changes from -2 to +6, so again the change is 8, and carbon no change. And if we consider here 2 8s are 16, 16 plus 6 again 24, so the 3 is matched with the yes. Similarly, you can even calculate for the arsenic sulfide, where the sulfur oxidation state is -2 and arsenic oxidation state is +3 here, and +3 changing to +5, ASO3 minus. Accordingly, you can calculate, and sulfur changes to SO4 -2. So, definitely you will get the oxidation state change as the 28. Okay, so this is how to match this type of questions. Now, next one. Based on the equation, E is equal to -2.178 into 10 power -18 joules Z square by N square. Conclusions they have given, and they are asking which is not correct. The first one, negative sign in the equation simply means that energy of the electron bonded to the nucleus is lower than that of the electron which is at infinite distance. Correct. Here we represent the negative sign for the energy of the electron. It means that when the electron is at is free, then only it is having more energy. If and its energy is taken as 0 at infinite distance, as it approaches the nucleus, its energy decreases, and hence we are showing with a negative sign. Larger the value of n, larger is the orbit radius. Of course, larger the n value, larger is the orbit radius, according to the Bohr's theory. And equation can be used to calculate the change in energy when the electron changes changes its orbit. E2 minus E1 or E3 minus E2, you can calculate excited energies or de-excitation energies. That is also correct. And what about this fourth one? For n is equal to 1, the electron has more energy than it does for n is equal to 6. No, it's not correct. See, suppose if we consider n square, which is in the denominator, right? In the denominator, if the value is more, it is overall less electronegative value, less magnitude you will get. That means if we consider with the negative sign, it is more. Did you understand or not? Once again, no doubt E is inversely proportional to n square, and with the negative sign, as n increases, the overall value is also increasing. That means for n is equal to 1, the electron has less energy when compared with the electron which is at n is equal to 6. So this is the wrong statement. So option D. Next, for the reaction 2A plus B gives rise to 2D, they have given delta U, delta S. It's not delta G, remember, it's delta U and delta S they have given. Calculate the approximate delta G naught value they are asking, and also predict whether the reaction may occur spontaneously or not. So regarding spontaneity, we have the equation delta G is equal to delta H minus T delta S. If we calculate delta G, if we get negative value spontaneous, positive value non-spontaneous, then how to calculate delta H? We have the formula delta H is equal to delta E plus delta nRT and minus T delta S. What is this delta N? The number of gaseous moles change, right? For this equation, there is the delta N is nothing but 2 minus 3, nothing but minus 1. So here delta E they have given as delta U, nothing but minus 2.5 into 10 cube. As it is kilocalories, we converted. And here minus 1 into R is nothing but 2 calories, and then T is nothing but 298 Kelvin, and then after substituting all these three terms minus T into that means 298 into delta S if we consider, that is nothing but minus 10.5. After calculating all these things, you will get the value as 0.033 kilocalories, which is a positive value, hence non-spontaneous, and hence option D is the correct one. The equivalent connectivities of K plus Al plus 3 and SO4 minus 2 ions are XYZ, and they are asking for limiting equivalent connectivity of potash alum. So here when they give the electrical connectivities, each ion number of equivalents also we need to calculate, right? So molar conductivity at equivalent conductivity at infinite dilution is nothing but number of equivalents of K plus into equivalent conductivity of K plus is X plus number of equivalents of Al plus 3 into Y plus number of equivalents of SO4 minus 2 SO4 minus 2 into Z, right? So how to calculate number of equivalents? It is nothing but the charge of the ion divided by total charge. Let us take the total charge here, either the cation or the anion. Suppose if we consider the K plus, there are two K plus ions, 2 into 1 plus there are 2 Al plus 3 ions. So 2 into 3 6. Total charge is 8. So if we consider the K plus ion, 1 by 8, 1 by 8, 2 units positive charge, 2 units is there. So 2 into 1 by 8, 2 into 1 by 8 nothing but 1 by 4 is the number of equivalents of K plus ion. So if we substitute number of K plus ions over there, you will get 1 by 4 into X. Similarly, if we consider the Y and the number of equivalents of Al plus 3, total charge 3. How many 2 Al plus 3 ions are there? 2 Al plus 3. So 6 by 8, nothing but 3 by 4. And similarly, number of equivalents of SO4 minus 2, nothing but here the total charge is 8, and that is 4 SO4 minus 2 ions. 4 into minus 8, 8. 4 into minus 2, nothing but 8 by 8, nothing but 1. 1 into Z. So the correct option is A. Now let's move to the next one. Consider the following carbocations, and they're asking for the stability of the carbocation here. If we consider the stability, we know the tertiary carbocation is more stable, and moreover, along with the resonance effect, we can also see the hyperconjugation in the fourth case, whereas the number of hyperconjugative structures are uh, 6 here, and whereas 3 in the case of 3, and in the case of 2, there is no resonance stabilization, and hence 1 follows by 1 and then 2. The correct order of the stability is nothing but 2 less than 1 less than 3 less than 4, more number of hyperconjugative structures, and the resonance stabilization makes the fourth structure most stable among the given, right? Let's move to the next one. A mixture of ethyl iodide and N-propyl iodide is subjected to Wurtz reaction. The hydrocarbon which will not be formed is. So in the case of Wurtz reaction, we know mixture of products are formed, and here N1 is equal to 2, the number of carbon atoms in ethyl iodide 2, and N2 is equal to 3 as it is propyl iodide. So we can have the alkanes with 2 plus 2 or 3 plus 3 or 3 plus 2 carbon atoms, right? So this is nothing but 4, this is nothing but 6, this is nothing but 5. So you can expect butane, pentane and hexane, but not propane. So which is not formed, they asked, answer is propane. Next one. The number of optically active products obtained from the complete ozonolysis of the given product. So whenever the complete ozonolysis takes place, we know that there is a cleavage of double bond, and we write double bond O here, and they're asking for the optically active compound. Let us see where is the chiral center. Let us see where is the chiral center after the complete ozonolysis. If we consider this carbon is having a CH3H, but this side also CH2 and this side also CHO. So same groups, so no, it's not chiral center. Similarly, this is double bond O, this is double bond O. This is not the chiral center, as two CHO groups are there. So there are 0 optically active products on complete ozonolysis of this particular compound, right? Let's move to the next one. So from the above compounds, correct order of reactivity in electrophilic aromatic substitution reaction. ARSC, aromatic electrophilic substitution reactions. We know that the plus M groups activates the ring, plus M groups activates the ring, and they are the ortho para directors, and minus M are nothing but the meta directors. And among all these three, this is showing that electron releasing tendency because of the hyperconjugation. It activates the ring by introducing the pi electrons into the ring, right? So the toluene is more reactive than benzene. Then what about Cl and NO2 here? If we consider benzene and chlorobenzene, though the chlorine is showing plus M effect, because of its minus I effect, it deactivates the ring and hence less reactive than benzene. Understand or not? So toluene with the electron releasing group, though the chlorine is electron releasing and plus M effect, because of its minus I effect, it deactivates the ring and hence less reactive than benzene. And what about nitrobenzene? Of course, it's an electron withdrawing group which decreases the reactivity of electrophilic substitution reaction, and hence 2 greater than 1 greater than 3 greater than 4 is the answer. The major product in the following reaction, HCl plus heat. So this is a aliphatic alcohol and this is a aromatic alcoholic group. Whenever we heat with HCl, only the aliphatic alcohols are replaced because the C and O minus ion here, if we consider, it is so stable because of that phenoxide ion. So we cannot break this OH group, and hence CH2OH is substituted as a CH2Cl and D is the product. Next one. The order of reactivity of phenyl magnesium bromide with the following compounds. Phenyl magnesium bromide reactivity, in the sense it is definitely a nucleophilic addition reaction, because phenyl magnesium bromide readily decomposes to give phenyl anion and magnesium bromide cation. So in the carbonyl compounds, if we consider, aldehydes are more reactive towards nucleophilic addition reactions, because if we consider acetone and acetaldehyde, acetone contains extra electron releasing groups which makes less positive charge on the carbonyl carbon, where the nucleophile readily can't attack. And because of the steric hindrance also, you can say that the acetone is less reactive towards nucleophilic addition reaction, just with that of Grignard's reagent, right? So among these two, the acetone and acetaldehyde is more reactive. After acetaldehyde, the less steric hindered group, CH3, if we consider acetone is reactive, and then benzophenone. So the order of reactivity is 2 greater than 1 greater than 3. The compound that undergoes decarboxylation most readily just on heating is, this is also one of the important point, especially if we consider the carboxylic acids. Alpha, this is the alpha and this is beta, and this is nothing but beta keto acid. Beta keto acids readily undergo decarboxylation and CO2 will be eliminated out just by heating. The CO2 gas escapes from the compound. Okay, so answer is B. Now let's move to the next one. See, if we consider this reaction NH2, aniline and the CH3, NaNO2 HCl, nothing but diazotization, NH2 converts into N2 plus Cl minus, and you know already this Gutterman reaction, CuC and KCl, which is replaced the CN here. So NH2 replaces N2 plus Cl minus. With KCN or CuCN, you will get a cyano group instead of NH2. So this is the correct answer. Simple reaction based on named reactions in the aniline. Now let's move to the next one. Which of the following compounds will have the reducing sugar in an aqueous KOH solution? So generally the aldehydes, if the carbohydrates have free aldehyde group in the form of hemiacetal structures, they readily reduce they are able to reduce the oxidizing agents, hence called reducing sugars. If we consider this particular structure, after treating with the KOH solution, it converts into hemiacetal form. That hemiacetal form is nothing but, see, suppose if we consider this one, it readily converts into O minus when it is treated with the KOH, whereby a alpha hydroxy ketone is obtained, and that particular alpha hydroxy ketone reduced by an oxidizing agent and hence called reducing sugar. Okay, now let's quickly move to the integer type questions. Suppose if we consider this question, how many of the following reagents convert into isopentyl alcohol into alkyl halide without any rearrangement? Here without any rearrangement in the sense, if we consider the PCl3, PCl5 or SOCl2 and PBr3, if we consider all these isopentyl alcohols readily convert into halide ions, whereas the other reagents readily forms a carbocation which there is a chance of rearrangement. Okay, total 4 are there. So here the number of revolutions are inversely proportional to the n cube, and for the second orbit is 8 times that of the revolution made by the electron in the nth orbit, and they are asking for the n value, right? So how to do this problem? See, as it is inversely proportional to the cube root, I mean not cube root, cube of n. Here we can say that number of revolutions F2 divided by Fn is equal to n cube divided by n2 cube. That means, so here the second orbit number of revolutions divided by nth orbit revolutions, if we consider it is 8, so we are getting the answer as 4. N cube is equal to 64, n is equal to 4, right? Now let's move to the next one. Here they asked for the percentage dissociation of H2S, the value of Kc for the reaction they have given, and volume also they mentioned. You can clearly check the solution here. And even for the next one, there is a solution here. You can cross check the answer. Let us see the last question in the grand test. It is about Aldol condensation. How many of the following can give Aldol condensation reaction? We know to give Aldol condensation reaction, the compound must have alpha hydrogens. Here compound A alpha hydrogens, compound B also contains alpha hydrogen, C also contains alpha hydrogen, and even the G also contains alpha hydrogens. The remaining does not contain any alpha hydrogen, does not give aldol condensation. So total of 4, integer 4. Thanks for watching the video. If it is really helpful for you, please like, share and comment. Thank you.